Hello all. Okay. So the summing amplifier consisting of two types. One is inverting amplifier, another one is non-inverting amplifier. So firstly I will calculate and derivate the equation for inverting summing amplifier. So we know that this is our operational amplifier symbol, right? So in this symbol I just grounded the non-inverting terminal input here, and I will apply two inputs for this inverting terminal, that is V1 and V2. Okay, here R1. So this is what about my feedback resistance RF. So R1, R2. Okay, we just taken any resistance value. So V1, R1, V2, R2 here. Okay, so this is what the diagram of summing amplifier. So same as we discussed in inverting and non-inverting amplifier. So firstly we have to calculate the input side current value, and then we have to calculate the output side current value, right? So now as well as we know that VA equal to VB. So here VB value is grounded, so that value is 0. So that VA also 0, right? So now at input side, at input N. Okay, so here I apply two input value so that the current value as well as two value, so that we will calculate the I1 I2 value, then add this value. After that we will calculate with the output side. Okay, so first I have to find the I1 value. I1 equal to V1 by R1, that is V1 minus VA. V minus VA by R1. We know that VA is 0. So V1 by R1. Okay. For I2, V2 minus VA by R2. So this value going to be 0. So V2 by R2. Okay. So now we have to adding these two values for finding I value. So I equal to I1 plus I2, then V1 by R1 plus V2 by R2. This is what our equation 3, and this is our equation 1, this is our equation 2. Okay. So now next one is we have to find the current value in the output end. Okay. At output end. Okay, so I equal to the current flowing through like this, VA to V0 through this RF, right? So VA minus V0 by RF. Okay, so now this value going to be 0. So minus V0 by RF. This is about our equation 4. Okay, then we have to equate equation 3 and 4. So equal to 4. So V1 by R1, V2 by R2 equal to minus V0 by RF. Minus V0 by RF. I just write this RF here to multiply in this two value. So V1 RF by R1 plus V2 RF by R2 equal to minus V0. Equal to minus V0. So in this condition, I will take all resistance values 1. All resistance values are same. That value is 1. So that this value going to be 1. Right. So V1 plus V2 equal to minus V0. I just write it here. V0 equal to minus of V1 plus V2. So this is about our inverting summing amplifier. So next one is about non-inverting summing amplifier. So in this non-inverting summing amplifier, we have to give the input here for this non-inverting terminal. So just I just cancelled, I just changed the terminals here. So here plus, here minus. Okay, so that the process will be same have to calculate the input in the inverting input side, and we have to calculate the current in the output side. Then we substitute these values. Then we will found a non-inverting output as V0 equal to V1 plus V2. There is no phase shifting. Okay. So for inverting summing amplifier means the values to be minus because of the values to be phase shifted. For non-inverting amplifier there is no phase shift. So V0 equal to V1 plus V2. Okay. So this is what about summing amplifier. Thank you.